So area of a circle, I'm pretty sure you've seen this formula before. The area equals pi times the value of the radius squared. So if you're given the radius, which most, I'm pretty sure in all of these problems, I'm either giving you the radius or the diameter. So if you know what the radius is, all you have to do is plug it into the formula and then type it in your calculator. I'm going to have you answer to rounded decimal to the 10th place. And that's it for area of a circle. Area of a sector. Well, actually, real quick, what if I wanted a semicircle? Right. Area of a circle divided by 2, or half of the area of a circle would be the area of a semicircle. Half of pi r squared. And then area of a sector is the other one. You have the measure of the central angle. In this case, it's 36 degrees. Here it's an X. I really like it with an M. I'll probably be using it with an M because that's the way I taught it whenever we went over circles. The central angle was M degrees. So it'd be M divided by 360 times the area of the circle, pi r squared. So basically you just put this in parentheses in your calculator and do it the same way. All right?
The X is 36, right?
Yes, in this case, that example X would be 36.
Okay.
Yeah. So I'm just going to go through some examples. It does say in terms of pi. I don't want to do this in terms of pi. We're going to round to the 10th place because that's how I have your test set up. So that's what we're going to do. What is the area of the circle? Well, all you need to find the area of a circle is the radius. Look at that. You have the radius. The radius is 5. So area equals pi r squared. So area equals pi times 5 squared. I could even go one more step, although you could just type it in the calculator like that. But I'm going to rewrite it as 25 pi, because 5 squared is 25. So it's 25 pi. And if I type that in a calculator, 25, and then press the pi button, it's 78.5. So the area is 78.5 inches squared. Straightforward problem on finding the area of a circle. Nothing complicated, right? On number 2, I guess you could say it's slightly more complicated because you're not given the radius. And this one we're given this 9, but that's not the radius. That is the diameter. A radius goes from the center to the outside edge, but not all the way across. That's the radius. It's half of the diameter. So the radius equals diameter divided by 2. In this case, it's 9 divided by 2. So it's 4.5. And that's all the extra work we had to do for this one. Now the radius is 4.5, so we plug it into the formula. The area equals pi. The radius is 4.5, and that is squared. I type it in the calculator, and it is 63.6. And these are in inches, and my units are squared. All right, so we had an example given the radius. And then we had an example given the diameter, so you cut it in half, and now you have the radius. And then number 3, this one I guess is more complicated. You don't have a picture, it's given to you in words, and it asks for the diameter. What is the diameter? So we need to find out what is D. We're given the area. The area is 153.9. So if I write out the formula, A equals pi r squared. And I know the area is 153.9. And that equals pi r squared. That means I can solve for r. And then once I find out what the radius is, I know the diameter is just 2 radii. So radius times 2 is the diameter. So to do this, I have 153.9 equals pi times r squared. If I'm solving for r, that means I need to divide by pi. So divide by pi. So you have 153 divided by pi gives me 48.7014. I want a lot of extra decimal places and round at the end. That equals r squared. But I don't want r squared, I need r. So to get r, I am going to take the square root to cancel out the squared. Bring that up over here. So r equals, in the calculator, I do the square root of 48.7014. The radius is 6.9786. That's the radius. But I want the diameter. And the diameter equals 2 times the radius. So the diameter equals 2 times 6.9786. Which is 13.957. Since I'm rounding to the tenths place, 9.5, the 5 tells the 9 to go up. So that's a 0, so that means this is actually 14.0. And these are centimeters. That's the most complicated type of problem you're going to have today. But it's not that bad, right? It's good. Questions? All right. Those are area of a circle, all 3 of those. I have 2 more examples of area of a sector. So this one has a different formula, area of a sector. So the area equals m degrees over 360 degrees. I like to put that in parentheses. And then pi r squared. So you need 2 things to solve for the area of a sector. You need the measure of the central angle, and you need the radius. For this first one, I have both of those things. The shaded sectors. A sector is just a section of a circle. So this 100 degrees, that's m, because it's in degrees. M degrees. And I see that 10 is the radius. So the area equals 100 degrees over 360 degrees times pi 10 squared. I could type it in just like that, but since this is the first example, I'm just going to go through a couple of things. One is the degrees are going to cancel. That's why my area is going to end up in meters squared, because the degree on top and the degree on bottom cancel. And then 10 squared, that's 100. All right, so then I rewrite this. Really, I would just type it in like that. You can either type it in as 100 or as 10 squared. It doesn't matter. So the area equals 87.3. And these are meters. And it's area, so the meters are squared. I guess since I'm showing units, let's write it with units. That's how I got meters squared. It's not necessary to always show the units in your work as you're showing work, because you could tell by looking at the picture what the units are going to be. If it's a linear measurement, it would just be meters. Like if I was asked for the radius or the diameter, this one would be meters. But since I'm asked for the area, I know it's meters squared. All right, I have one more. This one is a little different because I'm looking for the area of the shaded sector. Well, this 20 degrees, that is not pointing at the shaded angle, right? That's the leftover piece. So in degrees is the shaded one. I don't know what that is, but I know a circle has 360 degrees. And if I subtract the 20 degrees that's not included in that sector, then 340 degrees equals M. So this one had an additional step at the beginning. Now I have M and I have the radius. So all I need to do is plug it into the formula. The area of the sector equals 340 divided by 360 times pi 7 squared. Or you can type in 49 if you want to do that part in your head. So I just type it in the calculator just like that. Use the pi button. We're not using 3.14 for pi. We're using the button on the calculator. And that is 145, I think it was 0.37. So that rounds up to 0.4. 145.4.
Is this the homework for tonight? Today? Yeah.
Meters squared. So that's the area of the sector.